The Voyage of the Beagle by Charles Darwin. Chapter 1 Part 2 Santiago, Cape de Verde Islands. Fernando Noronha, February 20th. As far as I was enabled to observe, during the few hours we stayed at this place, the constitution of the island is volcanic, but probably not of a recent date. The most remarkable feature is a conical hill, about 1000 feet high, the upper part of which is exceedingly steep, and on one side overhangs its base. The rock is phonolite, and is divided into irregular columns. On viewing one of these isolated masses, at first one is inclined to believe that it has been suddenly pushed up in a semi-fluid state. At Santa Helena, however, I ascertained that some pinnacles, of a nearly similar figure and constitution, had been formed by the injection of melted rock into yielding strata, which thus had formed the moulds for these gigantic obelisks. The whole island is covered with wood, but from the dryness of the climate there is no appearance of luxuriance. Halfway up the mountain, some great masses of the columnar rock, shaded by laurel trees and ornamented by others covered with fine pink flowers, but without a single leaf, gave a pleasing effect to the nearer parts of the scenery. Bahia, or San Salvador, Brazil, February 29th. The day has passed delightfully. Delight itself, however, is a weak term to express the feelings of a naturalist, who, for the first time, has wandered by himself in a Brazilian forest. The elegance of the grasses, the novelty of the parasitical plants, the beauty of the flowers, the glossy green of the foliage, but above all the general luxuriance of the vegetation, filled me with admiration. A most paradoxical mixture of sound and silence pervades the shady parts of the wood. The noise from the insects is so loud that it may be heard even in a vessel anchored several hundred yards from the shore; yet within the recesses of the forest a universal silence appears to reign. To a person fond of natural history, such a day as this brings with it a deeper pleasure than he can ever hope to experience again. After wandering about for some hours, I returned to the landing place; but, before reaching it, I was overtaken by a tropical storm. I tried to find shelter under a tree, which was so thick that it would never have been penetrated by common English rain; but here, in a couple of minutes, a little torrent flowed down the trunk. It is to this violence of the rain that we must attribute the verdure at the bottom of the thickest woods. If the showers were like those of a colder climate, the greater part would be absorbed or evaporated before it reached the ground. I will not at present attempt to describe the gaudy scenery of this noble bay, because in our homeward voyage we called here a second time, and I shall then have occasion to remark on it. Along the whole coast of Brazil, for a length of at least 2000 miles, and certainly for a considerable space inland, wherever solid rock occurs, it belongs to a granitic formation. The circumstance of this enormous area being constituted of materials which most geologists believe to have been crystallized when heated under pressure, gives rise to many curious reflections. Was this effect produced beneath the depths of a profound ocean? Or did a covering of strata formerly extend over it, which has since been removed? Can we believe that any power, acting for a time short of infinity, could have denuded the granite over so many thousand square leagues? On a point not far from the city, where a rivulet entered the sea, I observed a fact connected with a subject discussed by Humboldt, in his Personal Narration, Volume 5, Part 1, page 18. At the cataracts of the great rivers, Orinoco, Nile, and Congo, the syenitic rocks are coated by a black substance, appearing as if they had been polished with plumbago. The layer is of extreme thinness, and on analysis by Berzelius it was found to consist of the oxides of manganese and iron. In the Orinoco it occurs on the rocks periodically washed by the floods, and in those parts alone where the stream is rapid, or as the Indians say, "The rocks are black where the waters are white." Here the coating is of a rich brown instead of a black colour, and seems to be composed of ferruginous matter alone. Hand specimens fail to give a just idea of these brown burnished stones, which glitter in the sun's rays. They occur only within the limits of the tidal waves, and as the rivulet slowly trickles down, the surf must supply the polishing power of the cataracts in the great rivers. In like manner the rise and fall of the tide probably answer to the periodical inundations, and thus the same effects are produced under apparently different but really similar circumstances. The origin, however, of these coatings of metallic oxides, which seem as if cemented to the rocks, is not understood, and no reason, I believe, can be assigned for their thickness remaining the same. One day I was amused by watching the habits of the Diodon antennatus, which was caught swimming near the shore. This fish, with its flabby skin, is well known to possess the singular power of distending itself into a nearly spherical form. After having been taken out of the water for a short time, and then again immersed in it, a considerable quantity of both water and air is absorbed by the mouth, and perhaps likewise by the branchial orifices. This process is effected by two methods. The air is swallowed, and is then forced into the cavity of the body, its return being prevented by a muscular contraction which is externally visible. But the water enters in a gentle stream through the mouth, which is kept wide open and motionless. This latter action must therefore depend on suction. The skin about the abdomen is much looser than that on the back; hence, during the inflation, the lower surface becomes far more distended than the upper, and the fish in consequence floats with its back downwards. Cuvier doubts whether the Diodon in this position is able to swim; but not only can it thus move forward in a straight line, but it can turn round to either side. This latter movement is effected solely by the aid of the pectoral fins, the tail being collapsed and not used. From the body being buoyed up with so much air, the branchial openings are out of water, but a stream drawn in by the mouth constantly flows through them. The fish, having remained in this distended state for a short time, generally expelled the air and water with considerable force from the branchial apertures and mouth. It could emit, at will, a certain portion of the water, and it appears, therefore, probable that this fluid is taken in partly for the sake of regulating its specific gravity. This Diodon possessed several means of defence. It could give a severe bite, and could eject water from its mouth to some distance, at the same time making a curious noise by the movement of its jaws. By the inflation of its body, the papillae, with which the skin is covered, become erect and pointed; but the most curious circumstance is, that it secretes from the skin of its belly, when handled, a most beautiful carmine red fibrous matter, which stains ivory and paper in so permanent a manner that the tint is retained with all its brightness to the present day. I am quite ignorant of the nature and use of this secretion. I have heard from Dr. Allen of Forres that he has frequently found a Diodon floating alive and distended in the stomach of the shark, and that on several occasions he has known it eats its way, not only through the coats of the stomach, but through the sides of the monster, which has thus been killed. Who would ever have imagined that a little soft fish could have destroyed the great and savage shark? March 18th. We sailed from Bahia. A few days afterwards, when not far distant from the Abrolhos islets, my attention was called to a reddish brown appearance in the sea. The whole surface of the water, as it appeared under a weak lens, seemed as if covered by chopped bits of hay, with their ends jagged. These are minute cylindrical confervae, in bundles or rafts, from 20 to 60 in each. Mr. Berkeley informs me that they are the same species, Trichodesmium erythraeum, with that found over large spaces in the Red Sea, and whence its name of Red Sea is derived. Their numbers must be infinite. The ship passed through several bands of them. one of which was about 10 yards wide, and, judging from the mud-like colour of the water, at least 2½ miles long. In almost every long voyage some account is given of these confervae. They appear especially common in the sea near Australia, and off Cape Leeuwin I found an allied, but smaller and apparently different species. Captain Cook, in his third voyage, remarks that the sailors gave to this appearance the name of sea sawdust. Near Keeling Atoll, in the Indian Ocean, I observed many little masses of confervae a few inches square, consisting of long cylindrical threads of excessive thinness, so as to be barely visible to the naked eye, mingled with other rather larger bodies, finely conical at both ends. Two of these are shown in the woodcut united together. They vary in length from 0.04 to 0.06, and even to 0.08 of an inch in length, and in diameter from 0.006 to 0.008 of an inch. Near one extremity of the cylindrical part, a green septum, formed of granular matter, and thickest in the middle, may generally be seen. This, I believe, is the bottom of a most delicate colourless sac, composed of a pulpy substance, which lines the exterior case, but does not extend within the extreme conical points. In some specimens, small but perfect spheres of brownish granular matter supplied the places of the septa, and I observed the curious process by which they were produced. The pulpy matter of the internal coating suddenly grouped itself into lines, some of which assumed a form radiating from a common centre. It then continued, with an irregular and rapid movement, to contract itself, so that in the course of a second the whole was united into a perfect little sphere, which occupied the position of the septum at one end of the now quite hollow case. The formation of the granular sphere was hastened by any accidental injury. I may add that frequently a pair of these bodies were attached to each other, as represented above, cone beside cone, at that end where the septum occurs. I will add here a few other observations connected with the discoloration of the sea from organic causes. On the coast of Chile, a few leagues north of Concepcion, the Beagle one day passed through great bands of muddy water, exactly like that of a swollen river; and again, a degree south of Valparaiso, when 50 miles from the land, the same appearance was still more extensive. Some of the water placed in a glass was of a pale reddish tint, and, examined under a microscope, was seen to swarm with minute animalcula darting about and often exploding. Their shape is oval, and contracted in the middle by a ring of vibrating curved ciliae. It was, however, very difficult to examine them with care, for almost the instant motion ceased, even while crossing the field of vision, their bodies burst. Sometimes both ends burst at once, sometimes only one, and a quantity of coarse brownish granular matter was ejected. The animal, an instant before bursting, expanded to half again its natural size, and the explosion took place about 15 seconds after the rapid progressive motion had ceased. In a few cases it was preceded for a short interval by a rotary movement on the longer axis. About 2 minutes after any number were isolated in a drop of water, they thus perished. The animals move with the narrow apex forwards, by the aid of their vibratory ciliae, and generally by rapid starts. They are exceedingly minute, and quite invisible to the naked eye, only covering a space equal to the square of the thousandth of an inch. Their numbers were infinite, for the smallest drop of water which I could remove contained very many. In one day we passed through 2 spaces of water thus stained, one of which alone must have extended over several square miles. What incalculable numbers of these microscopic animals! The colour of the water, as seen at some distance, was like that of a river which has flowed through a red clay district, but under the shade of the vessel's side it was quite as dark as chocolate. The line where the red and blue water joined was distinctly defined. The weather for some days previously had been calm, and the ocean abounded to an unusual degree with living creatures. In the sea around Tierra del Fuego, and at no great distance from the land, I have seen narrow lines of water with a bright red colour, from the number of crustacea, which somewhat resemble in form large prawns. The sealers call them whale food. Whether whales feed on them I do not know, but terns, cormorants, and immense herds of great unwieldy seals derive, on some parts of the coast, their chief sustenance from these swimming crabs. Seamen invariably attribute the discoloration of the water to spawn, but I found this to be the case only on one occasion. At the distance of several leagues from the archipelago of the Galapagos, the ship sailed through 3 strips of a dark yellowish or mud-like water. These strips were some miles long, but only a few yards wide, and they were separated from the surrounding water by a sinuous yet distinct margin. The colour was caused by little gelatinous balls, about the fifth of an inch in diameter, in which numerous minute spherical ovules were embedded. They were of 2 distinct kinds, one being of a reddish colour, and of a different shape from the other. I cannot form a conjecture as to what 2 kinds of animals these belonged. Captain Colnett remarks that this appearance is very common among the Galapagos Islands, and that the directions of the bands indicate that of the currents. In the described case, however, the line was caused by the wind. The only other appearance which I have to notice is a thin oily coat on the water, which displays iridescent colours. I saw a considerable tract of the ocean thus covered on the coast of Brazil. The seamen attributed it to the putrefying carcass of some whale, which probably was floating at no great distance. I do not here mention the minute gelatinous particles, hereafter to be referred to, which are frequently dispersed throughout the water, for they are not sufficiently abundant to create any change of colour. There are 2 circumstances in the above accounts which appear remarkable. First, how do the various bodies which form the bands with defined edges keep together? In the case of the prawn-like crabs, their movements were as co-instantaneous as in a regiment of soldiers, but this cannot happen from anything like voluntary action with the ovules, or the confervae, nor is it possible among the infusoria. Secondly, what causes the length and narrowness of the bands? The appearance so much resembles that which may be seen in every torrent, where the stream uncoils into long streaks the froth collected in the eddies, that I must attribute the effect to a similar action either of the currents of the air or sea. Under this supposition, we must believe that the various organized bodies are produced in certain favourable places, and are thence removed by the set of either wind or water. I confess, however, there is a very great difficulty in imagining any one spot to be the birthplace of the millions of animalcula and confervae. For whence come the germs at such points? The parent bodies having been distributed by the winds and waves over the immense ocean. But on no other hypothesis can I understand their linear grouping. I may add that Scoresby remarks that green water abounding with pelagic animals is invariably found in a certain part of the Arctic Sea. End of Chapter 1, Part 2. Recording by Scott Robbins.